In section 5.4, we're going to talk about solving special systems of linear equations. So I want you to look at the key idea at the top of page 226. Now, a system of linear equations can have one solution, no solution, or infinitely many solutions. So the first thing I want you to look at is our first graph. We have two blue intersecting lines. Because the lines intersect, we have one solution. In the second example, we have two parallel lines. Because the lines are parallel, which means they have the same slope, they're never going to intersect. Therefore, we do not have a solution, so our answer is no solution. And in our last example, we have two lines graphed, but it's ultimately the same line. And because the lines are the same, we have infinitely many solutions. So now for example number one. Example number one, we have two equations, and we want to solve it. Now you guys can graph, and that's okay. If you want to graph, that's fine. But since I look at this and I see that something is already solved for y, I'm going to use substitution. So I'm going to take this right here and plug it in for the other y. So if I substitute the 3x plus 1 in for the second equation for y, my equation is going to be 3x plus 1 equals 3x minus 3. If we solve the basic equation, subtracting 3x on both sides, they cancel. That means I'm left with 1 equals negative 3. Well, that's a false statement. 1 does not equal negative 3. So because it's a false statement, my answer would be no solution. More importantly, though, I want you to know that you can do this a separate way. So I want you to write down the same problem again. Since both equations are actually solved for y, you could look at this part right here and say, I have the same slope. Because you have the same slope, you know that the lines are parallel, meaning that it would give you no solution. So let's look at another example. Example number 2. Y equals negative 5x minus 2, and 5x plus y equals 0. In this equation, we also have one of our letters solved for y, or one of our variables by itself. So because we have an equation solved for y, I'm going to use substitution. I'm going to take the negative 5x minus 2, plug it in for y, 5x plus, and then I have negative 5x minus 2 equals 0. 5x minus 5x cancels, so that gives me negative 2 equals 0, which is not true. Therefore, my answer is no solution. Once again, one other way we can do it is solving both equations for y. If you solve both equations for y, the first equation is already done for you. The second equation, you'd have to subtract 5x, so you would get y equals negative 5x. Because they have the same slope of negative 5, it would also be no solution. In number 2, I want you to write down this problem. The perimeter of the rectangle is 36 units. The perimeter of the triangle is 108 units. Write and solve a system of linear equations to find the values of x and y. So the first thing we're going to do is write an equation for each of these. If you look at the rectangle, we know that these two other sides are also 4y and 2x, but I labeled them incorrectly here, so let me go back and erase them. Well, it's not letting me erase them, so I'm just going to cross them out. This would be 2x, and this one would be 4y. Well, because we're talking about perimeter, that means we add up all the sides. So all we do is just add up all the sides. So 4y and 4y gives us 8y. 2x and 2x gives us 4x. That gives me a perimeter of 36 units. Now we write an equation for the triangle. We add up all the sides. 6x plus 6x is 12x. Plus the 24y. Notice I'm lining everything up. And that gives us a perimeter of 108. Because everything is lined up, I'm going to use addition method. So because I have the addition method, I'm going to cancel, let's say, the x's. So because I want the x's to cancel, this is 12x, I need to make this negative 12x. So I would multiply the first equation by negative 3. If you multiply by negative 3, that gives me negative 24y minus 12x equals negative 108. The second equation comes straight down, and you'll notice that everything cancels. So my equation is 0 equals 0. That is a true statement. 0 does equal 0. So because it's true, that means they're the same line. My answer is infinitely many solutions. I want you to write both equations again. 4x plus 8y equals 36, and 12x plus 24 equals 108. What I would like you to do is solve each of these equations for y. So pause the video, do it yourself, and then come back to the video. So if you solve them for y, you would have 8y equals negative 4x plus 36. You divide everything by 8. That gives me y equals negative 4/8, which is negative 1/2 x, plus 36/8, and we'll just leave it like that for now. You can put a decimal or a simplified fraction. The second equation will give us 24y equals negative 12x plus 108. Divide everything by 24. Negative 12/24 also gives us negative 1/2 x. And I'm going to divide 108 divided by 24. And that gives us the fraction of 9/2 or 4.5. So we could put 4.5 here. And if we take 36 divided by 8 over in the first equation, you would also get plus 4.5. You have just proven to me that those are the exact same equation. So your answer would be also infinitely many solutions. So there are also other ways to do the same problem. Let's do another example, number 3. X plus y equals 3. X minus y equals negative 3. In this equation, in this system, you'll notice that both equations are already lined up. So my y's are going to cancel, so I'm just going to add them together, get 2y equals 0. Notice the x's did not cancel. So I'm going to divide by 2, x equals 0. I got a value of x. So I plug it back in. That gives us 0 plus y equals 3. So that means my solution is 0, 3. This is one solution, and it's 0, 3. Let's do one more. Example number 4. 2x minus 4y equals 10. And negative 12x plus 24y equals negative 60. Pause the video, solve this yourself, and then we'll go through it and see if you did it right. So in this problem, what you should have done, or what you could have done, is since everything is lined up, to multiply by something to use addition method to eliminate a variable. So in this problem, I'm going to get rid of my x's. Since this right here is negative 12x, I want this to be positive 12x. So I'm going to multiply the top by 6. If you multiply the top by 6, you get 12x minus 24y equals 60. On the bottom is negative 12x plus 24y equals negative 60. Everything cancels. And because 0 does equal 0, your answer is infinitely many solutions.